In the next example we have s plus 3 over s squared plus 4s. One way to do this is to factorize the denominator. We could use a partial fraction method. Both factors in the denominator are linear factors. They involve s to the power of 1, so we would just have constants on top, a and b. So we have a times s plus 4, that's as plus 4a, and we have b times s. So comparing the numerators, since the denominators are obviously the same, we have s plus 3 equals a plus b times s plus 4a. Is this an identity? True for all values of s. That can only happen if the s terms are the same, or the coefficients are the same. So we must have that a plus b equals 1, and we must also have 4a equal to 3. The constant terms are equal. So we see that a equals 3/4. So that means that b must equal 1/4. 3/4 plus 1/4 is 1. Okay, so we go and look up the inverse transforms of these. Well, we're going to get 3/4 times the inverse transform of 1 over s. We can see that the inverse transform of 1 over s is u of t. We can also get it from rule 4. If we plug 0 in for a here, we get 1 over s, and e to the 0 is 1. So we'll end up with u of t using either 2 or 4. Now what about 1 over s plus 4? Well, that's straightforward. We can see it's got this form with a equal to 4, so we get e to the minus 4t. Well, we have to plus 1/4. E to the minus 4t times u of t. Next we have 2 over s plus 1 times s squared plus 1. Now I will get the partial fractions of this. So one fraction has s plus 1 as denominator, and the other fraction has s squared plus 1. Now the fraction with the linear denominator has a constant term for the numerator, but the other factor is quadratic, so its numerator has to be linear in s, so I will call it bs plus c. So we get the common denominator, and to get the numerator we multiply a by s squared plus 1 and bs plus c by s plus 1. So we get bs by s, then we have bs by 1, then we have c times s, and finally c times 1. So gathering up like terms on top, we get this here, and it must all equal 2. So the s squared terms have to be the same. A plus b must equal 0. The s terms have to be the same. B plus c equals 0. And finally the constant terms have to be the same. A plus c must equal 2. So if I take this equation and subtract this one from it, the c's will go out. So we get b minus a equals 0 minus 2. And we have this equation up here, which is a plus b equals 0. I'll write it as b plus a equals 0. Now, so adding these two together, we get 2b equals minus 2. So we see that b equals minus 1. Now if b is minus 1, a must be plus 1 to give 0 here. And if a equals 1, we see that c must equal 1 to give 1 plus 1 equals 2. Okay, so we fill in for a is 1, b is minus 1, c is 1. Let's look at this fraction here. I'll write this as minus s over s squared plus 1 over s squared plus 1. So these should be familiar. These are the cos and sine. The inverse transforms involve cos and sine, these two here. Well, let's start with 1 over s plus 1. Well, that's e to the minus at, where a is 1 in this case, so we'll get e to the minus 1t. 1 to the minus 1 t. 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 1 to the min For the next one, comparing to this one here, we can see that a squared is equal to 1. So that means a is the square root of 1, which is 1. So we get cos of 1t. And for this one here, we have 1 over s squared plus 1 squared. So that fits this exactly. So a is equal to 1 for this one. So we get sine 8t, sine 1t. And if you like, you can put in the u of t. This is all multiplied by u of t.